Good afternoon, everyone. And am I too loud? No. To continue the previous session's theme, my name is Sam. One of my advisees is a graduate student getting a PhD at Indiana in 1 week. Yeah, it's for her, not for me. And I'm here to talk to you about scripting GIMP. GIMP is the GNU Image Manipulation Program. I think most of you knew that. I'm using Racket. And I'm from Grinnell College, a small liberal arts college in the middle of more or less nowhere. And so the context is about a decade ago, our department was rethinking our intro course. The obvious part was that we were going to use Scheme for our intro course. The stupid decision was we just didn't adopt how to design programs, but that's okay. We looked at other directions. And we had three main inspirations. First was Mark Gusdile was showing a lot of success at getting particularly women to stay in CS by doing image computation and other things. Students also seem to be very excited and continue doing their computer science homework even after they've met the requirements. Looking further back, Mike Eisenberg has this wonderful thesis at MIT on scheme paint where he looked at what it means to script applications and that as a motivational tool for people who might not otherwise want to program. And then my colleagues Henry Walker and John Stone had been doing workshop-style CS for 15 years before, 10 years ago. And so we wanted very much a workshop style wherein most of class time is students exploring, not listening to someone like me at the front of the room, because you don't really learn listening from me at the front of the room. Well, maybe me, but other people you don't listen to. And so we thought about the fact that, nice computer, GIMP comes with Scheme. There's a nice little Scheme console here, and maybe you can even see it. Maybe not. And it's real Scheme. You can type complex expressions like 2 plus 3 and get 5, but you can also control GIMP. So we can, draw as normal. We can set the color. And learn to type in front of an audience. So I'll do a shade of red, more or less. And you can see now I'm drawing in red, and I can, this isn't very exciting, this you can do in lots of things, but of course it's GIMP, so you can choose really interesting brushes. And draw with vines as opposed to colors. And so it's a little bit more powerful than many ways we think about drawing. And we have this amazing IDE, which is resizable, sometimes. Oh, look, you can make it larger. And if you type incorrect scheme, it gives you really helpful error messages like EOF. And you can enter fractions. Well, okay, maybe you can't enter fractions. So it didn't really seem appropriate for our introductory students. Now, at the time, we'd already been using this wonderful, great Scheme environment called Dr. Scheme. And so we looked at how we could take Dr. Scheme and make it work with GIMP. Nice computer. Is the text legible at the back? Okay, so here's a simple program that takes an arbitrary image. This one is also resizable. And draws an X on it. So it starts at 0, 0 as the top left corner and goes to the width across and the height down, so that's that diagonal, and then it also draws one from the width across and no down across, so I can say, for example, run and do this wonderful thing on image 1, and you can see we now have an X drawn in vines. Maybe we should see a different brush. GIMP does not necessarily have the best brush names. And there you go, you can see the X a little bit better. So we have some potential for doing some simple things. But the other thing we noticed about using, actually, let's see. And it means you can start doing things as you think about them programmatically that aren't necessarily possible just directly in GIMP. Like someone could have done that by hand. But you can't like rapidly change the color while drawing. So we can write a loop. I apologize for my scheme style or my Racket style, but you can write a nice little loop that every 1/10 of a second changes the color. And I think it's running. And so you can see as I draw, the color gradually changes. And so this shows students that with very little scheme, okay, they did have to understand recursion or some kind of looping structure, you can build new tools that weren't there before. But there's a little problem here. Other than that old console being just a console, this doesn't feel very functional to me. Does it feel functional to you? No. And why do we love scheme? We love scheme because it's functional. So one of the things we started to do was look at ways we could provide them with more of a functional model of images within the GIMP. So the simplest one is thinking of an image as a function from positions to colors. So we have our nice little lambda expression that takes the x-coordinate and the y-coordinate and gives you back a color. In this case, the red component is the x-coordinate, the y component, the blue component is the y-coordinate, and the green is some function of the two. And if all goes well, we see a nice little horizontal blend there, and you can see if we change the functions we use, we can make the whole thing crash. Let's see. Never do a dog and pony show. Let's see. Do I want to terminate? Sure. Oh, that was fun. How many people have been in this situation before? Oh, good. I feel a little bit better. This is not DrRacket's fault. You'll notice that at the top it says unsafe. That's because it's my code. So let's see, that was the image compute. From there, we start looking at transforming existing images. So we have a picture of a kitten that we use a lot that we found a few years ago, and it's in the public domain. And so we can have them do variants on it. That's probably the wrong one. Let me do a simpler one first. Should be 4. There we go. Okay, so here's our kitten. Here's our kitten. There we go. Isn't it nice? Don't you have a good feeling? Don't you want to see some random badly garbled text on it to be funny? And we can say, well, I want a variant of that image. And here's the function we're going to use on each color. And I'm just going to complement each color. And we want to show that image, conveniently represented as an integer, and you see a functional model of transformation that's pretty clear to our students. From there, we can start talking to them about more higher order programming issues. So for example, they learn that there's an IRGB subtract function that takes 2 colors and subtracts one from another component by component. And so we can say, well, image variant's supposed to take 2 parameters, an image and a single parameter function. How do you make a single parameter function from a 2 parameter function? It's time to learn cut. And so we can remove all the red from an image with that nice little expression. There we go, and it actually worked. And there's our kitten with no red. And what else do you think about when you're doing these transformations? Well, you may want to do more than one transformation. And so if you want to do more than one transformation, you probably need composition. And composition's a little weird because the order of operations matters a whole lot. So we can either subtract all the red and then complement, or complement and then subtract all the red Is there a scheme convention for compose? I was discussing this with my colleagues. Anyone use a particular symbol for composition?
There's a word compose.
Okay. We use a little O because it looks more like math, but maybe we should have used compose. And you can quickly see that they start to learn, think about functional operations visually. So here we've complemented and then, no, there we've complemented and subtracted all the red. Here we've subtracted all the red and then complemented. Let's see, 5, 6. So this is sort of pure functional, but sometimes we want to do a combination of things that feel GIMP-like and things that feel functional. So there's a selection tool in GIMP, like there is in almost every graphics program. So we could programmatically select something and then transform just the selection. I use complement because it's really easy to see. So, hello kitten, and we've complemented. So there are immense power to, you know about the power of scripting. The students quickly see there's an immense power to scripting. Do I have one more? And then here's something that's probably going to make you feel uncomfortable. Every color is represented as an integer, which means that the way we transform each color doesn't have to be a color function. We could be multiply by 2. And so we can look at our kitten with each color multiplied by 2. And it makes no graphical sense, but you can get some fairly interesting effects. And I'll hope this one doesn't crash the computer like it normally does. And I can never predict these, but this is what happens if you multiply every color by 1.4. At least it seems to be what happens if you multiply every color. So the students have a lot of fun playing with the different effects they can get in abnormal ways. Now this breaks typing, so I don't think we can ever use DrRacket for this because I'm treating colors as numbers, but it helps the students understand that there is an underlying representation that they have to think about. So that's it for the pretty pictures for now. Let me talk a little bit about what we've seen. So we knew from the Ghazal work and from the Eisenberg work that students are motivated by making and manipulating images. And it's really fun for me when I walk up to their computers and their desktop is something they made in my class. I showed you higher order programming. We do that in week 2. So they learn cut and compose in week 2. That's not a normal intro CS class. They learn cut and compose before they learn how to write their own procedures with Lambda. The thing we didn't expect is that the students say, like, when my code doesn't work, I look at the picture, and the picture helps me figure out what's wrong. And that's such a great experience, right? Like, seeing 5 when I expected 2 doesn't tell me a lot. Seeing, like, it black over here when I expected white actually seems to tell them something. And we also find that, as people who like to teach math, this model really does help them think mathematically, because you can't really do graphics without some math. Behind the scenes, what are we doing? Well, we needed a way to hook up 2 programs. We're Linux people. I had one of my students look into it. He said, dbus, use dbus. So we used dbus for this, which means we had to extend GIMP, which at the time didn't support dbus, to support dbus. The internal GIMP scripting engine didn't really believe anyone would want to deal with pixel level data in large chunks. Those are what they call tiles. So we had to build a tile iterator as a plugin for GIMP. The scripting language assumed we use triplets for the colors. That tends to use a lot of memory and make the garbage collector start a lot, so we tend to use an integer representation that you saw. Then we needed to make Racket communicate on dbus, and it was probably late at night, so we gave this wonderfully funny title. Racket on the dbus? No, okay, it's not wonderfully funny. And then the other thing we found about GIMP scripting is that it's not easy. Students have to think about layers and weird commands. So we spent a lot of time building a Racket wrapper around most of the complicated built-in things, and then we also had to do some parts in C. So it was really fun writing the image variant thing that has to take the GIMP model and take in the beautiful lambda that I get and somehow apply it to each pixel. That was great. And it really was. There are lots of problems. One is an obvious one that someone was going to ask, which is Racket's already great graphically. We just saw that on the previous talk. Why bother with something new? And we really do feel that application scripting is a powerful model for students. They learn that they can build something not just for themselves, but that someone else could use. Like once you have that, make the brush change the color and it actually does something interesting, or once you have a new filter, you can share that with someone else. That's a powerful feeling. And that's different than, look, I built an application that you have to run from the command line. This is like, we can plug it into GIMP and you're fine. dbus is Linux mostly. I think there's a Windows implementation. I think there's a Mac implementation. They're kind of funky. So this only works on Linux right now. GIMP is not always expecting us to do what we do with it. So occasionally a student will make something happen and they'll look at the screen and nothing has happened. And we know that it's happened because we can like query the image, and that's a difficult thing. The GIMP designers didn't say, oh yeah, you should be able to programmatically choose which brush you use, and which brush, but not like, do we use a paintbrush or an airbrush? And then I coded this before I thought enough about Racket, so it's really ugly scheme as opposed to really beautiful Racket. So if you ever look at my code, you will discover that. And I bet I am right at the time that Sam wants to say it's time for 2 questions. Or 1.
Well, first let's thank Samuel.
Oh, thank you.
So we definitely have time for a couple questions, and also for the next speaker to start setting up.
I've inspired no questions. So. Oh, there's one in the back and one on the side.
So you said that Racket has a couple of ways of producing pictures already, and that's certainly true. Could you turn your interface to GIMP into a way of programmatically building things without having to have GIMP, active and running and on the screen, and use GIMP as a library from Racket, sort of invert the relationship?
Given sufficient time, yes, probably. GIMP will run headless. I have not tried to do so. Time is an amazingly limited part of life, but yes, that's probably something that should go on the list of things to do. And I saw...
I sent you an email about a page I saw yesterday at Strange Loop about a Cambridge project. It's art. Just check your email.
Thank you, Jeffrey.
Surely that's good advice for all of us. So let's thank Samuel again.